In this tutorial, we will create some components that will allow us to rotate the camera and the player. The tracker controller will help us track the player's position. Currently, this is done with the help of the camera controller, but the camera controller will be obsolete after this tutorial. The rotation controller will apply the actual rotation via the rotate method. The getAxis controller will help us figure out how many degrees we want to apply a rotation. It is an abstract class similarly to the getKey controller, which allows us to create mock classes for simple unit testing, or an implementation that queries the actual input axis, for instance the mouse movement in X direction. Please be aware that during recording I use different names for the getAxis controller and its implementations. But for naming consistency I later refactored this. We begin by creating the scripts for our tracker controller. It only needs one test to make sure that we are actually tracking the position. We create a target and a tracking controller and assign the target as a GameObject wrapper. We use this wrapper so that we are able to assign a GameObject or a GameObject handle. After changing the position of the target, we will call our track method and then assert that our track controller is at the same position as the target. We also add the missing fields and then run the test. We now implement this tracking method and this component is already done. In our demo scene, we remove the camera controller from our main camera and create a new GameObject which will track the player. We make the camera a child of this GameObject so that the camera will always maintain the same relative position to the tracker as long as we don't change it. We add a tracker controller with the player handle as a target, and the new update controller will call track. And now the camera controller should still follow the player. We then add the rotation controller. First, we want to implement a simple 90 degrees horizontal rotation. We add a rotation controller and a GameObject which we will rotate around. Again, we will use our GameObject wrapper for this so that we also can assign a GameObject handle. Before we can apply the rotation, we have to change our position. In this case, we set it 1 unit to the right side of the around GameObject. Rotating 90 degrees from there means we should end up in a forward position. After adding the missing fields and methods, we will run the test. Naturally, it fails. In the implementation, we can simply use Unity's rotate around method. We rotate around the GameObject's position. The rotation axis is the up vector. And lastly, we need the number of degrees we want to rotate. Running the test reveals that I messed up the direction. In this case, it is feasible to simply fix the test. Next, we want to implement a 90 degrees vertical rotation. We set our position to the right side, which is actually the vector 100, and our rotation axis will be the forward vector. Which means that after rotating 90 degrees, we should end up in an upwards position. After adding the missing axis field, we run the test. In the implementation, we will use the supplied axis. This test now works, the other test will fail. We fix this by defaulting the axis to vector up. Now we want to make sure that our rotation axis is applied locally and not globally. We set the position below our rotation point and then look upwards. Now, after applying a 90 degrees horizontal rotation, we actually should have rotated vertically to the left or the right position. We solve this by multiplying the rotation quaternion with our axis. And it seems in our test we guessed the wrong direction. Let's try it in our demo scene. We will add an input for the rotation and I set it to E, which we will connect to a rotation right event handle. We add an update controller to check for the input. For now, we add a rotation controller to the camera to rotate around the player tracker. And we want to rotate by 10 degrees when rotate right is fired. The camera behaves odd because we are now rotating around the up vector of the camera, which means we need some kind of switch to decide whether we want to use global or local vectors for the axis. So let's add a test for a global rotation. We still want to look up, but our position will be to the back side of the rotation center. The space we want to use is now world space, which means we now have a simple horizontal rotation to the left or to the right side. We add the missing field and run the test. In the implementation, we now simply check against this field and apply the axis with or without rotation accordingly. And of course, we messed up the expected position, so we simply fixed it in the test. The rotation local test now fails because the space enum defaults to world. But this was easily fixed. And now we rotate around the player as we expected. I have also refactored the axis we actually use in a private property. And running our tests shows that it still works. To bring the rotation controller more in line with other components like the translation controller, we will not apply the rotation to the game object of the rotation controller directly, but to a target, which means we add a target field and update all our tests with this target. It is important in test-driven development that you carefully think about how your interfaces, your functions, your methods will look like. But even if your interfaces change, like in our case right now, as long as your components are fairly small, then refactoring the tests shouldn't be so much of a hassle. We now expect all of our tests to fail. And now we must apply the logic to the target transform instead of this transform. We want to implement a rotation via mouse movement, which means that now we need to implement our axis controller. It will let us check how much the mouse has moved in the X and Y direction, and this movement can be applied to the rotation. First, we add the axis controller scripts. We now add an abstract base axis controller. It will have one abstract method that needs to be overridden by its implementations. This method is supposed to retrieve the current axis input. Our axis controller will use Unity's input getAxis method for this. In our tests, we add a mock implementation, which simply stores constant axis values in a dictionary. The axis value is supposed to be retrieved and applied to a Unity event when we call an apply method. In our first test, we instantiate an axis mock and add a listener to retrieve the axis value. We set this axis value to 0.3. We also need to define which axis we want to retrieve before we call apply and assert our result. We also add a test to assert that the onApply event is not null. Now we add the missing fields. We create our own event by inheriting from Unity event so that we can serialize it to the inspector. And I made a mistake here. It should be a float event, not a vector event. One test can be fixed by initializing the onApply event. And for the other test, we simply implement a minimal approach by invoking onApply with a fixed value. We add a test with different values for different axes, and by retrieving an alternative axis, we assert also an alternative value. Now we actually use the getAxis method. I have also added two other fields. One can invert the return value, the other one can multiply it. This can be very helpful in configuring our behaviors. The corresponding code, as always, can be found in the repository. We now remove those components from the camera controller. We then add the rotation game object. We will now configure the horizontal and vertical rotation for the camera. I renamed the rotate right event to rotate. And the new event listener will listen to this event. I also set the corresponding input controller to mouse button 1 and hold. We now add an axis controller to our horizontal game object, which will be called by our event listener. The axis controller will query the mouse X axis and multiply its value by 5. Lastly, we add a rotation controller, and the axis controller will call its rotation method with the current axis value. The rotation controller needs a camera handle and a player handle. So let's create the camera handle. And we add a corresponding setter to the camera. Now we can assign the fields in the rotation controller. And now in play mode, horizontal rotation should work. We duplicate the horizontal object to create a vertical object, where we need to adjust axis and space in the rotation controller, and the axis in the axis controller. I also inverted the axis direction here because it felt much better. And now we have a free camera rotation. We can also add a player rotation by letting the player rotate around itself. But we will later add a better solution for this, because our current implementation would need a 100% synchronized movement of camera and player at all times. And this is something we might not be able to guarantee. We can now update our prefabs with our new creations. I completely unrolled the main camera in the scene to disconnect it from the prefab. And then we store a new camera prefab. That's it for this tutorial. Next time we will build on what we created this tutorial and make some adjustments. Let me know what you think, and thanks for watching.